Hello, hello. Another stream on bionicchaos.com, as per usual. This is mainly to get your feedback on the web applications. Hopefully, you already tried them out. If no, please go to bionicchaos.com. There's quite a few useful tools there already for you to check out and let me know what you think. So I'm just checking how the stream sounds. Oops, that will go into the stream. Will keep repeating itself in a loop. But at least I do have this sound. What are we doing today? First of all, just about it on a LinkedIn. Post in a group and then delete it once the stream have ended. Well, LinkedIn is offering me to put this post on another group as well, which I'm happy to do. You have to follow the bot. You have to take the bot's advice. Not sure how bad is my fans are getting into the microphone, which is set to quiet on the motherboard, but it's still quite noisy. I mean, yes, this one is rolling at 100%, the CPU one. Not entirely sure why is it doing that. Certain things that I can close. So now we got the server, the Bionicchaos, Bionicloud, whatever server called, connected to fiber optic. We got the, well, it's essentially unlimited. Meant to be like a 1 gigabit connection, but I'm still using Wi-Fi. So it's not wired to the router, so I'm getting about 300. Problem is that my upload is seem to be capped. And what a better way to test it than a live stream. So currently I'm not dropping any frames, but yeah, I'm sure if I keep increasing the rate, it will reach the ceiling. And with the noise which so it's these two CPU fans that going a bit move it this way, be quieter, and the other one as well, move it that way. This should be better. So now the fans are not throttling, but we will just keep monitoring that, see how that goes. Because yeah, when I'm using the tools on my own machine, it will be using the GPU. So it should be not putting any load on the CPU. But if you access them remotely, at the moment the GPU would not be used. So you will be relying on my CPU. Which I don't think is ideal. I'm looking into changing that. So normally on this channel, we test the tools. There was a minor update to this one. It should look slightly better on a smaller screen, especially on like a mobile screen. Can still hear the fan. Oh, I don't. Ooh, which one's that? Don't get it. One of those that has like a question mark. Is it actually there or? It sounds like something was connected to it. This one is also going. Well, yeah, we don't want it to overheat, so yeah, we could have a mode for a live stream, because yes, when you select this to be quiet, it's not actually quiet. This one's going, but I can't hear it. Don't think there's actual fan connected there, but I'll do this anyway. Move it to the right slightly. Should keep it quieter. Yeah, I'm not entirely sure. I don't think those fans are actually connected. I'm not entirely sure. Let's try this. Yeah, with this tool there was a bit of a bug that could be considered a feature, where when you use any of those sliders, it's actually the same anywhere where you have a slider like this on bionichaos.com, where it keeps sending GET requests, which is a bit unusual. So I'm not sure if it's a bug or this is how it meant to work. Anyhow, this can generate another way of an abnormal EEG. If you increase this noise, it's actually skipping beats. I already discussed it before, but it has to be made clearer. I don't know how. Here's something else clicking in my PC. I think it's one of the GPU fans. It's a bit clicky. Restore my brightness settings. Just check the chat. Sometimes OBS YouTube API is not really working. No, it is working, but that's okay. So if you click on this on one of the sliders once, it just makes one call, one API call. But if you actually slide it left and right, it makes like 100 of them. Yeah, we'll call it a feature, but it wasn't intended. So this tool generally is working okay. Do we have cross coherence? And this one is working fine as well. But again, that's my bias perception of it. Yeah, actually, this one, the slider is more responsive. So when you scroll, it then stops scrolling. Whereas in here, if you keep scrolling, it will keep making API calls. I'm not sure why. Just one sec. Yeah, BPM noise of 40 is already quite high. The gaps in the spikes are very prominent. We had that statistical analysis. I think we were planning to do some more changes to this, but at the moment, probably better to start a new one instead of touching this one. We have the old review tool. There's something wrong, something that I'm doing. Making some sort of mistake somewhere in the code. I'm not sure if it's the API itself or calling it. It must be calling the API. We had this bug of, yeah, again, the slider. So it's either I'm getting rid of all the sliders or have to fix it at some stage. If anyone knows, if anyone used those before and had something similar, any funny business with sliders, please do let me know. Again, this is one of the older tools, so we'll leave them as is. Eventually, we also need to add some more description to these things, but I can make it, can do it offline, and eventually, all the videos like this one, I'm editing them, making them shorter, and eventually will be transcribed, hopefully by YouTube. And that could be used as a blog as well. So that's the plan. Or the additional feature on the website. Yeah, I can really hear that fan clicking. It's like a very expensive GPU. I guess something happened in shipment. Did I have it for under a year? Will it be still under warranty? Yeah, but yeah. This tool is working okay as well. Yeah, so the play button will be delayed depending of how long you is scrolled, because at the moment it keeps sending more and more get API requests, and now it's done, and it's the play function is on. In this spectrogram, when you load the page, it meant to, yep, if you load it again, it just works. Now it works again. So I don't know how to reproduce this thing where you load the page and it's actually not showing you the waveforms. It's pretty annoying. I don't know what's up with that. Channel. Yeah, this labeling is not great, is it? It should be hide active channel instead of certain channel. Make it should be clearer, should it? Overlay option. Yeah, the left and right should be there just as the default, and this could be reduced to like 300, 200 or so. Also the window size, is it too small? Yeah, my GPU will start. Ooh, there's another bug. They can fix it straight away. When you change the window size, it should update. It's not updating. I guess it will update if I scroll this. Ah, yeah. Yeah, it does. It becomes less responsive as well. But when you change this, it should update the window without scrolling. So let's fix that quickly. We get back to business. Which one is it? This one. Spectrogram HTML. And we need to add this window size. Ooh, this is for window size. Right, fast scroll. Need to add cases. A window. It should be it. When you change, yep, this is better. Quick fix. This one, let's just check if this description is correct. It's a frequency spectrogram example that demonstrates another way to review EEG. Was it another way? The main way. Another way. Click Should play a bit then on the left side. So again, we'll leave it as is. Yeah, it really becomes not very responsive if the window size is large. It's mainly because this one will have like 128 channels or so. So this window will be quite heavy. Here some fans again, and this will not be the CPU, will it? So probably be the GPU. Let's check the CPU. Oh, this one. Still here, sorry, wait, there's actually another fan going. No, it's in like a regular fan, not a computer fan. But I did turn it off. To start monitoring the GPU as well. Not sure some of these things are not actually connected to anything, so I'm not sure why they show up in here. Wait, there are, was it 10? Yeah, I do have about 10 fans in the machine. Mm. But I don't think the three ones in the front, I think they're all connected together. I had to also give them proper names. And still something is going. Must be the GPU. That's less of a problem because no, I'm happy for it to keep going. It's just it's just the other thing. If you stop this, click the shortcuts. So we had some earlier tools. So now I'm scrolling with left button. So you can use left and right to scroll, but I don't have as much keyboard shortcut control as I do if the tool is fully LabVIEW, so standalone LabVIEW. But maybe I'm wrong. Maybe I can add extra shortcut features to be used in a web browser. Yeah, obviously it becomes much more responsive if the window size is smaller. Eventually I'll be cleaning up all the live streams. Potentially also turning them into regular videos, but that might, it just takes forever to edit the things, which I just don't have. Just prefer to spend my time in a different way. This tool again, ideally we would have would like click on the table. Let's just check if we have this functionality. So when we click on it here, something, let's go back into annotations. Annotations. So when you do has only one one event case. Question is create reference. So create reference to this and do that key focus label. Key focus, what? A visible disabled key focus value? No. The question is vision size, no. Something that's heat, no. Label, key focus. It's just binary thing. In LabVIEW, you can just get there are options to detect which raw is selected, but I cannot find this feature in here. That's not good. Wait, it's called data. What? It's called data grid? It's called data grid. Read. Doesn't have this function, does it? If I change this and create reference, it's called okay. Key focus. No, selected selection. Yeah, this is what we this is what we want. Is selection. Select the data. Select the data. Select the data. We add the stuff into this. Mm-hmm. Yes, properties. Okay, how do you put group string data? Okay. Tree. No. Sorry. How do you? Come on. Sorry. That. How do you write the papa? How do you write anything into this tree? And is it better than a data grid? Should be better because we have this option for getting selection out of it. So what we're trying to do is, instead of having an additional index that you could just click onto here, and this selection, pretty sure in LabVIEW you can do it, this selection will be just exported as a number, what's it, 7 in this case. But can't seem to find a way. First of all, this data grid doesn't have a selection output. A tree does, but I'm not sure how to populate the tree. Populate this tree. This data grid. Wait, how do you populate the data? How did I? Ah, yeah. Oops. Sorry. You just just click on it there. Why create ref? No. Yeah. To populate this thing. Okay, first of all, let's save this as a new let's how do I save it as a new VI web? We will have to, we haven't made too many changes. We just discard the changes for a second, but we have to figure out how this tree works, because potentially it's better than this data grid, which is essentially just a table. I'll just revert it back to what it was. Do we have unplaced items? The trending and whole spectrum. The trending and whole spectrum. So this is in the API. By the way, what is the API? Let's just put it as one string, because we will need at some stage to do documentation. This is it. So this is how you call the API. Put it as a, turn it into some sort of document. Oops. Later, but yes, that's the API that you can call. What has so many trailing zeros? Save this. And why is this window size? What's its default? It's 10, is it? It's yeah, it's 10. It's actually starting off as 100. Change this to 10. Change that to minus 100 to 100. Just so it's loading, it should be loading quicker. And we could add all those window size and have to trend window size to trend. What else did we have? And whole spectrum. Whole spectrum. Right. Can add the trend. Whole spectrum. And window size. This. Yeah, the training should be doing a lot for something like this. because it has a lot of DC in the signal. All spectrum, yes, works okay. And the window size. So that will be the time, the initial T0, T0 starting time. And then you could change your window size if you wanted. But default 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 is 10, the trend default is on, and whole spectrum default is off. That's okay. And publish this at the end of the stream. But this will be a short one as well, because some friends were complaining that the streams are way too long. And as I said, eventually I do go and make them shorter, trying to keep them to one topic only. But it just takes some time, well, because they are long, but also because they are on YouTube already, and when I stream I don't actually save locally. So this one will be updated later. The new changes. In this feature extraction, we need to try some EEG and ECG in it. It will find the features. Problem with this image is that it have this algorithm has like a calibration images. I think was it a different algorithm to look at it again, but essentially we want to have an image of an EEG or ECG trace, and for it to label that, because obviously this example is not very relevant to biomedical engineering unless you're using something like this in surgery. This was a joke, by the way. And again, the new tool will be probably separate to this anyway, because because this one just works. It's quite handy to see to assess the difference between these three different algorithms. But yes, it will be interesting to see that one of the ones that performing poorly on this particular task will be performing better on EEG or ECG. So that will be an interesting experiment to do. And we make a note of it, and have to break this task into multiple pieces. And hopefully it will appear soon. But that being said, there is actually another a tool that is labeling labeling ECG. This one. There's another noise reduction thingy, which is quite handy, especially if we can use a tool like that. It's actually using. Yeah, it's very sensitive. This one is less sensitive. So you can essentially use like a graphical tool like this to determine how much noise you want to leave or remove. And eventually, if it's too high, you get your signal removed as well. So not very useful. Or you can set it to remove just a little bit of noise, but then you get a, well, yeah. So it will be case specific. File from terminal. Yeah, ideally, I don't know. This tool was created ages ago. Yes, they need to be able to select different. Yes, you can. Right, but some of them it doesn't actually works well. It's something with real noise in it, so none of the synthetic noiseless signals. That sound, yeah, works okay for this. That's yeah. Not sure when adding this NI vision. Change. Wait, but that doesn't change anything. Sure, what's that doing? This one. Yeah, this algorithm is quite finicky. And the question is, do we have a source code for this to check that we convert that open front panel convert? We have the source code, doesn't look anything like. We have another tool there, another tool here. We have help, those things. Threshold, TF chart. It's using iMac vision, just the LabVIEW image processing, discrete Gabo transform. That's a standard thing. Yes, we want to get it down to like textbook stuff. If this is GTFA refnum get graph, great for sniffing binary mask. It looks like it is the source code, which is great, because we had another earlier tool we tried to use and there was no source code. I might take this one offline, but it is a useful tool to play with. But that's actually not what I was originally looking for. I was looking for. Did I really turn it into? Yeah, ECG feature extractor. The one. Yep. Yes, something like that. I actually made quite a few changes to it. Originally, it only had 3 waveforms, but in ECG you want 4 of them. I was just trying to turn this one is unmarked, turn it like white color, and then have essentially T wave in blue, P wave in say green, and the Q wave, QRS wave in red. Oops. But yeah, oh, come on. I can also change it later. Is this the one? Well, right. This is all the source code for it, is it? Ah, extract ECG features. No, that's the main function. I think that's the one. That's some sort of checking. Then you had this one features, and this is the one that I don't have source code for, which is unfortunate. So eventually we'll have to use something else, but we could use this for comparison's sake. This will be another way of labeling data. So this essentially will, but the result will be similar to what we have here, but optimized for ECG. Whereas this one more generic. Just check. And same fuzzy logic. We wanted to work on some more meaningful signals, not just trapezoids and squares, as much as they are fun. You could just have like an envelope of QRS shape, for example. But um, yeah, that will be. How do we do that? Might take this one offline as well. Think about it. some more. I mean, ECG is easy, right? You have that detect that doesn't make any mistakes. There's one here, and yeah, this one wasn't like trained on any specific ECG waveform. It should just work middle. It changes this. You need to preset those, or here is detect threshold factor. Anyway, but this algorithm is obviously specific to ECG. So yes, we need to test it with just a random ECG. I will do it with, can I record my own? But no, if you need that 9, was it 9 or 12 leads to get all the features, don't you? Yeah, I'm not actually sure about the ECG. It in theory be easier than EEG because it's more predictable. Well, unless something goes wrong. Yeah, like your noise, BMP noise. If it's way too random, then would the algorithm still work? We can check that. Let's take it step by step. This thing we already turned, yeah, last time we already turned this into an API by adding this bit of code. That input there. Yep, that's what's turning it into a web service request. Then we wait. Where's the control H? That's select signal type. So we have an option of 3, and then it will give us all this stuff as output. We give us the whole ECG, P wave, QRS, and T wave. And we published this already. I think we did. Just check the web server. A LinkedIn friend was saying how they're not interested in, the web server and LabVIEW and this and that. Just give me the algorithm, whatever. But the without all this stuff, like you wouldn't even, no one would even have access to this at all. But yes, you do want to keep the right balance between, essentially data engineering and data science. Obviously, you're trying to optimize for data science. Nobody really cares how your tool was made, but you kind of have to a little bit, just the right amount. Let's check if what's BC ECG. Yes, it was published before. Let's see. Yeah, I want to use the secure version URL. Pop it in any browser. Select any type. Make it 0. Ooh, JSON, unexpected. This is actually fine, I think, because those are the nans, which is okay. I'll be able to sort them out, I think. Yeah, those nans. So where in the image we don't have anything like the red will be just that and gaps in between. So say if you take QRS, put a probe on it, this probe is way too large. And also, why is this probe? Okay. Yeah, you will have a lot of nans and that the QRS will be there. So there will be nothing, then QRS. Anyway, you get it. You get the gist of it. So this one is okay to use, I think. So we can create an API call like we did many times before. Should we use one of those things that has a template? Just check it as that Google syndication. Google syndication. Sounds fancy. But I need to keep that line there for the site to be monetized. Obviously, when we create a new tool, we actually don't want it to be monetized, but we're able to turn off monetization from the Google AdSense thing. And again, it's one of those things that nobody cares about, but I do. So bear with me. Okay, question is, can we use one of those as a template? So what eventually that web application GUI will look like? We don't want it to look like the original thing because it's pretty bad. But yes, it essentially has one window with the ECG. Yeah, it's pretty basic. So just one window and bunch of values output that you could ideally have them as a calculated per window instead of for the whole thing, because this is a 30-second ECG with labeling, but those values could be calculated for a specific window that you select, not the whole thing. And also, so I assume it's using 7.5 seconds for training and then starts labeling after. And this is how do you reduce this time or set it? And we don't have a source code for all of it, so might not be able to tell. So all that algorithm needs is some limits, APR intervals. You have to say that T naught is not needed. Need a rough estimate of the highest heart rate. Should be doesn't seem to do anything. This is reverting to default because that's a clone. So it's being controlled by this. Where's the input for this thing? Anyway, back to the API. So we created this. It should work already. Should be easier for me to troubleshoot it in once the API is created. I'm just looking for one of the previous APIs to use as a template. So it will be something like this with just one chart. You need one chart. Should be like that. And some, well, those won't be input values, they will be output values. We can use this as a template. We have the one chart. What's this one called? ECG generator, ECG gen. Let's create a copy. Duplicate. ECG gen, and this will be ECG labeling. In name ECG labels. G labels. I need to tick this box in here so the API will be available on the site, and we need to get rid of most of this. So first, this will be the API call. This will be 0, 1, or 2. Have 3 options. And that will be the only input at the moment. The only input. For the birds. Only input. Sorry, getting distracted by the YouTube analytics thingy. Check my sound as well. Still going okay. Well, yeah, 'cause this microphone is wired, so obviously it's not going anywhere. G feature extractor. Yeah, it's a better name. G feature. Whoops. What did I do? Add. And to click rename. Rename. G feature extractor. Okay, so we only have the one input for now. Yeah, later we'll combine the two. We'll have a generator and extractor to compare to see how well the feature extractor is performing on like a more randomized ECG. So essentially you could increase the noise in the ECG generator and see when this algorithm, the feature extractor, starts failing us. But for now, just have the two separate things working. The signal, like signal type, make it signal type, signal type. Was it select signal type? Of course you need to select it because it's an input, but yeah, silly name, but I'll leave it as is for now. Change the array. Oh, come on. How do you size to content? Yes. Signal type. And that one only has a normal. Normal. Remove that. Then it has Cardiograph. Yeah. Yep, that's it. This is a G type. Essentially, the only thing we need can get rid of most other things. Control V. Rid of that as well. On top there. Oop. Make this short. Let the output there. And clean it up a bit. Don't need all that space. Keep it simple. Simple, stupid. No type. Yeah, it's fine. This seems like a bug where you need to select it again. Need to change the name, so get rid of that. That's the actual API. And yeah, when we will have much more things in the output, so 4 different waveforms and more. We have 4 different waveforms coming out of the JSON file. Select the signal type. We have normal, tachycardia, hyperkalemia. And we'll have many more different outputs. Pretty much all of this. We save this as no, can't add it as an image, can we? It's unfortunate. Wait, just put it on another screen. One sec. This one needed on another screen. Back to this. Okay, need to change the name. It's called the where is it? ECG. And then we have the name of the API. What? Why is it? Oh, is it variant free? Yeah, must be. It goes here. We do need the question mark there. Just check the output of this. Will give us an error for now, but the debugging 1. What? No. No. Wait a second. Where is what terminal is on what? All right, the tank. Okay, EG signal type. A create reference. Pop that reference in here, so that will be the default value will be 0. It's the normal ECG. Right, now it's executable. Right. So just make sure that this API call is correct. Pop it in any browser. Yeah, it is correct. This arrow, you can ignore it. It's to do with the nans in the signal. I'll be able to sort them out. That's okay. And then we have a bunch of things in the output. Pretty much anything with a curly bracket. Or wait, how do you here, final page. Yeah, it's essentially all these bits. So you have a heart rate mean. So this will be a regular it's just a integer. We need the name, show label. Why is the label not showing? Show label. Right. The label is there. So we have. Oh, wait, this is a problem. That they have spaces in them. I had trouble with it last time. The API works. Maybe just for the input. I think the input here needs can't have spaces, but the output is okay to have spaces. We have heart rate, standard deviation. Whoop. Take this one out for a sec. Heart rate, standard deviation. QRS, amplitude mean. Mean. QRS, amplitude, standard deviation. Time, QRS time, mean. I think if I test it now, it will give me an error. Don't know. Well, one second to grab some water. So we're turning this into an API. It's an ECG feature extractor that will label T-wave, QRS complex, and P-wave. I'm still learning how it all works, but there's nothing better than just creating a tool out of it. So we made quite a few changes to the original example. And I think we already halfway through making this API call. So the call is just as the signal type as an input, and it's simply one of these three ECG waveforms. It's the input to the API. We're sending a GET request with it. We check that this bit should work, and now we looking at what's in the JSON file in the output, and we have quite a few things there. So we will stop at QRS time mean. Then we have QRS time standard deviation. So pop this in here. That's so this function knows what are we picking up out of the JSON file. What's next? Right, and now we have the ECG waveform. So this will be an array, obviously. Well, not obviously. Nothing is obvious these days, is it? So I have to sneeze. I'll turn off my microphone first. And it went away, as it always does. We should have 4 of these waveforms. Might make more space as well. Right, so we have the ECG. Can pop it in here. We should also have, where are we? We have some more integer types, more information. So PR, a interval, mean, and we can create another one of those. Pop it straight in there. Come on. No, it's just the keyboard shortcuts do not always work. We have DT, yes, as expected. So pop DT in there. We have PR interval standard deviation. Make another variable with that name. Pop it in this. It's called cluster constant, which is the input to our JSON function, which would not work unless it knows what's inside it. And then we, just to test it, we need ECG and delta T, and this should already work. Right, it does. That's great. Yeah, so this is the whole ECG signal, not labeled, without the features. It's 30 seconds of it. Where is it from? Some random recording. It's good that so we know the API is working. We can get rid of this because we don't make regular HTTP calls. The API is now secure. So it's using a different port, which by the way you can also use. If you don't like my user interfaces, you can make your own if you wish. More than welcome to. put it in a different screen, sorry. Just so I don't have to, Alt tab doesn't really work. So we have PR, interval, standard deviation, and now we have a P wave, which is an array, and this one has nans in it, so non-available entries. So would be interesting to see. So if it did something like this, P wave, right? So that works. So that will be just the P waves. So much DC on this signal. Should probably remove this E first, just to filter it out. So eventually we'll have to put them all together. So what else do we have? E wave. We have QT, interval mean, which is another integer variable. I don't know why they not in order. It shouldn't matter, but just keep it in the same order as the JSON file. Then we have another integer variable. It's the isoelectric level standard deviation. It's straight in there. Now we have the QRS, which is an array again. And this should work just fine. Oops. No, we don't want to do that. We want to take the whole thing, not just one item out of it. Let's just check it. QRS. Right, so this will be just the Q and the R peaks. And eventually we want to combine waveforms. How do we do that? Band? No. Band? Oh, we just want to overlay it, do we? We're just creating an array. In an array function. Array. Build array. Let's say, oops, no, just on this one. And same delta t. Clean this up. Then we have a QRS and P wave. Then we put a P wave in there. Just come on, make it. P wave. This should have multiple waves. Yes, it does. This is awesome. Yeah, I'll have to change the colors in there. and the order would be important. We haven't finished when you have ECG. ECG. They all have the same delta t, or at least they should have the same delta t. Would be, so it's just overlaid over the original ECG, which I probably want in some sort of grayed out color. Actually, probably like this. Ba-bum, ba-bum. I need to be able to select the window size and scroll through it. Anyway, we also have the T wave. Need to get the names right. This will be the last fourth waveform. And we have some other stuff. So electric level, mean, value. The problem with this is that this values, the measurements are for the entire 30 seconds. So I'm thinking when you select your window size, the output, the measurement values will be just for that window, not the whole wave. We'll see, that will be an upgrade later. Maybe later. Everything is maybe later, isn't it? Another one. I think super long, but that's okay. We can eventually pin it down. Where the dock to node. Yeah, so it's just hidden there. Oh no. We'll display the whole thing just so we see what are we dealing with. We have 2 more to go, so it should be quick. Bear with me. And the last one, the QT interval standard deviation. That should be it. Now we have 4 waveforms, we said, right? Let's put delta t. Can we just move it? Oops. What is that? Yeah, before when I tried doing something like that, would have crashed on me. Just disconnect that for a sec. Connect all the delta t's together. We'll have the whole ECG. Then you have your T wave. Then you have your QRS, then P. Then you have your delta T. Delta T should be wired to this. So the delta T should be the same. And then just remove. So the whole ECG can go first. Then we have, move it a bit, tilted T wave, URS, and P wave. Easy. Let's save these. We haven't saved anything for a while. Let's run, see if it works. So why? Yeah, the first one comes up in red. We'll make it some sort of like transparent. We'll put it last. Oop. It will change. Oh, come on. Don't change the wiring. How the... No. No. This shortcut for the wiring to stay. No. What if I write this in? No. Still have to rewire. Put ECG last. What? Stuff something up or what? It's like the color of that last thing. It's probably green, same as the background. Let's check the colors. They have red. What? It is greenish, so it's just disappearing in the background. What's the first one? Keep the names. But I don't have the names there. Array, waveform. Don't have the names. Some cleaning up. Do it. Oh, this is not good. Got to add that. Should be better, isn't it? Right. So now I can see the green. The green, the last one is the whole. Let's display plot legend. We have T wave. We have QRS. P wave. And we have all ECG, just ECG. Same state. Actually move the mouse for it to be for it to take effect. Right. Move 3 pixel width. We can make URS red, E-wave blue, E-wave green. No, wait. We have green as this. Make it right. What? What? Yeah, that last one can be semi-transparent. Can yeah. That looks okay. Don't like the dotted line. It's not great. Reduce it to 1 point. Oh, it's below. Reduce to minus fill to minus infinity. Yeah, it's not normal for ECG to look like that, but I wish I'll wait until someone uh, picks on it. Just leave it like that. The only thing I don't like that orange. The orange color is not great. For some reason. That one is red. Oh, and the QRS black. Yeah, the feel. None. Black doesn't really look like it's labeling. And how do I change the window size? and we just pop all the measurements on the right here. Just have to be clear that those are not input variables, the output measurements. And yes, we want to change the input size. Yeah, the scroller view. What? Why is the red meant to do that? It's as if it's transparent or something. Oh, okay. Yeah, just leave it like that for now. We're good to get rid of to have an option to get rid of that low frequency just filter at it's got 0.5 something hertz. Yeah, it's a very low frequency noise in it. That's right. Look like doesn't look like 3 times thicker than the original one. Yeah, those are weird. Those are not the same as what you have in LabVIEW. Uh, is what it is. Let's see. Let's quickly see how it looks like in the browser, because sometimes it can be very different. Wait, made a mistake. Ah, no, that's correct. It's yeah, no, it's fine. Yeah, I'm not sure why it looks funny like this. And I expect in different browsers it will look differently. Mm. Yeah, it's funny. Yeah, the rendering of this thing is not great, but yeah, I don't want to mess up with this too much. have to specify what the algorithms I used. Obviously, this was for the G. It's third, apparently. A beta release. And this is an ECG. Using LabVIEW. Yes, same thing. We need to add the scroll option and a window size scroll option, and the calculations should be made on that specific window size, not the whole. And select that window, not the whole signal. Pa, 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 pa. Okay. Extract what is insert, right? With that plots that draws charts different that breaks that labels and it's equal colors by splitting ECG wave into 4 subwaves. Into T Why is this stuff still in there? Plot 1 shouldn't be there. E URSB. It's weird. Looks like some sort of buggy thing. P wave URS and P wave. Yeah. Much. What it does is we'll have more background on it using this action. The more info on it. And LabVIEW, that's super old, probably from 2014 or something. It's almost 10 years ago. ECG, extract. And yes, ideally we'll do something similar in a Python or MATLAB or R. Probably first MATLAB, then R, and then Python. Yeah, so the LabVIEW biomedical toolkit was first released back in 2012. I don't think it had any updates since image extraction. Yeah, I can put this one in for now. What is it using LabVIEW functions? Content LabVIEW biomedical toolkit. This link, but if it's that link is not working again, there's nothing I can do about it. LabVIEW biomedical toolkit. When someone did something in some paper. There was a paper, wasn't there? There is a paper. That paper is, but just looking at the this paper. Yeah, this is all the measurements that we record. I might finish it soon and take this offline. There's also this meetup that I'm attending. It's a hybrid, should be a hybrid. There should be a Zoom link. If you have any comments, questions, suggestions, complaints, please do let me know. This paper in as well. Not using. Oops. It's running. Stop it to be able to edit it. In the example, just put all this in one paper call. Paper. Relevant paper. Put another link in there called this. And its link is that. Put it all in one. Just think it's the data because the signal part. Yes, data recording. What? No, is that one display signal? Yeah. Well, that's kind of obvious. Right. Pretty sure this is the same settings from the original examples. So that's what they are using as well. Look, should I just look for 120? Kind of bandpass filter. They're using different values. Right. They're using DEC. Sorry, touched the microphone. Hopefully it wasn't too bad. Yes, they're recording. They're filtering the data coming out of the digital to analog device. That's okay. Doing denoising. Okay. We could use that as well. We'll edit next. Collector. This is And that's interesting. Ah, mm, fire signal rate extractor. Right, so using this, what's the difference between this and that? That's the source code. It does a peaks and valleys, and there's a source code for that one. That's interesting. Put it in label. Yeah, that's okay. Why this aligned? That one delayed. This normal? Doesn't look like a great paper as well. You wouldn't normally publish. I mean, I do publish stuff like that, but but I mean, in a paper to see graph like that. I have 6 participants. Relax after run, mean. Relax after run, mean. Go from 60 down to 140. Funny. Number of samples. Why is it not time? Well, this just the same scale. So why do they have? Ooh, why have two y-axis where they both go to 160? No, no, no. Very bad. Bad graph. So in most cases it's the same 60 to 160, except this one here that goes down to 80. Like, what? Why? Rubbish. Oh, they have more participants. Because what you would expect if you just had the one axis that this green after run will then go down to relaxing. I don't understand what they're even trying to do. Ooh, the smoker subjects and non-smoker subjects. Okay. Must all make sense to someone. So where's the summary? You would expect to have a summary of, the smoke no versus no smoke. If that's what you're going for. Is it an ECG model? module. Never seen anything like that. I use this one. Oh, right, that's right. Okay, this is a regular NI DAC. It's a simple DAC, and that's the AD8232 ECG module. Okay. It's like sorry, I don't know anything about it. It must be super great. 8, 9. We get a good, fairly good. What's the signal? Yeah, okay, I get a fairly good signal out of it. Like some, I'm not sure what's the Tiga energy. To look it up. Anyway, yeah, it's a relevant paper. Just put a link to it. Just say that. Do they have? It's only 3 seconds. That's just an example. No, I get it. Birth samples. Where was it published? I never heard of this journal. Hmm. Itself. Yeah, it's essentially self-published. Yes, it's not any much better than what I do because these guys are from the Zachariah University and the paper called Zachariah University Journal of Science. So there you go. But it's the most relevant thing that comes up. That ECG amplifier as well, do you really need it? It's another amplifier, right? It's an analog device. Yeah, it's this circuit, single lead. Single lead. No, you do need it. It's only gain of 100. You can do 2 or 3 electric configuration. Oh, yeah, basic stuff. Is this the whole board? No. No, that's just the one chip. And they use the module for it. Okay. It's like everywhere. AliExpress. Some of it comes with electrodes. Do have some electrodes. But yes, it's good to know that with 3-lead ECG is what you need. You can get a fair enough, good enough. Right, so it's originally Spark Fund, and Spark Fund have a website. You have just yeah. Anyway, I'll have a look into just getting one of those. I wonder what kind of ECG I could record without that. Just connecting 3 leads directly to the DAC. I have a different one, so I can set it in a different way. Necessarily need an amplifier. I don't know. Anyway, we'll try it some other time. We'll also publish this tool soon, probably tomorrow. So I'll see you tomorrow. Have a good day.